This video is going to be covering adding vectors, but non-perpendicular vectors. So this is the second way that we can go about adding vectors algebraically. So for going about doing this, we need to determine the components of the triangle that we create. Okay, so just as a review from geometry, just our different angle rules, remember that with two parallel lines that are intersected by a singular line, remember that alternate interior angles are congruent, so these two are congruent and these two are congruent, and exterior alternate angles are also congruent and congruent. Okay, remember too that if you have a flat line, that would be 180 degrees, and then when we have the perpendicular lines, that would be a 90-degree angle. So those are just some reminders of some common angle rules. Also remember that the sum of all interior angles of a triangle would be 180 degrees. We can utilize that sometimes to help us solve for a certain angle. And then when we are adding non-perpendicular vectors, we're going to use two of the laws, trigonometry laws. So the sine law and cosine law. So sine law is this here. So side A divided by sine of angle A is equal to side B over sine of angle B, which is equal to side C over sine of angle C. Okay, so when we go about solving these problems, it's important to stay organized and label all of your sides. Okay, so side C should be opposite of angle C. You'll see that with B and A as well. Okay, so we use the sine law when we are given two angles and one given side. Okay, so if I was given angle B and angle A, and I had side B, I could use my sine law. Okay, or if I'm giving two sides and a non-included angle. Okay, so if I was given C and B, the included angle would be A because it's found between these two sides. So in order to use the sine law, I would need C and B, and then like either angle B or C because they're not included in between C and B. Okay, the other law is cosine law. Generally, this is going to be the one that you start with whenever you go to solve. So we use this when either three sides are given. So if sides C, A, and B are given, we can use the cosine law. Or if we have side angle side, which is generally what you're going to have in the situations that you're going to be solving. So side angle side would be if I have C and B, and then I have the angle that is included between them. So CAB, or if I had CBA or ACB. All right, so here are all those equations, and so we would just plug in the information from that. Okay, these equations, both the sine law and the cosine laws, I will be giving you. You do not have to memorize those for a test or anything. So to practice, we have Erwin walks 25 meters west, 15 degrees north, then 110 meters south, 40 degrees east. Find our displacement. Okay, so to start, I'm going to go ahead and make my compass so that I have a reference point to draw my first vector. So my first vector is 25 meters from the western border, 15 degrees north. So when I go to draw this in, okay, it's going to be 15 degrees above this western border, and it's 25 meters. Okay, then, so I'm going to go ahead and make another compass here just to help me have reference points for my other vector. Irwin then goes 110 meters south. So from the south border, so here's the south border, 40 degrees east. Okay, so to draw this one from the south border, 40 degrees east, and we went 110. So this right here, from the south border to the vector, is 40 degrees. Okay, so our resultant vector would be this. Okay, and we'll want to know basically what this is here, theta, for our direction. Okay, so to start, we need to have either 3 sides given, we need a side angle side, or we need 2 sides with an unincluded angle. Okay, so to start, if we look right here, we created 2 parallel lines, okay, with our compasses. So here's 2 parallel lines, and we have a line that is passing through them. So since I know that this angle here is 15 degrees, I also know, because of opposite interior angles, okay, this one here will also be 15 degrees. So I'm going to go ahead and label that. So this is 15 degrees. So I can find that the interior angle inside of the triangle, so this one here, okay, I can solve this because here is a 90-degree angle. If I know that this portion is 40, this part is 15, I could subtract 90 minus 40 minus 15 in order to find this angle inside of the triangle. And when I do that, I find that it is 35 degrees. Okay, so now I have, or I know, a side, an angle, and a side, and that angle is included. So I have side, angle, side, thus I can use the cosine law. Okay, so before I start to do the cosine law, I'm going to go ahead and assign the different sides of my triangle. So I'm going to make this side A, I'm going to make this side C, and then this side B. So then the angles, this would be angle A, this would be angle C, and then this would be angle B. Okay, again, like I said, it's best to try to organize your information. So plugging in to the equation I'm going to use is c squared is equal to a squared plus b squared minus 2ab cosine of angle C. So my c squared is delta d, and it will be squared. And then I have a squared, which is my 110, plus my b squared, which is 25, minus 210, 25, I've run out of room, cosine of my angle C, which is 35 degrees. Okay, so when I solve for this, okay, I find everything that I have on this side, and then I'll take the square root of it to get delta D by itself, so don't forget to take the square root. But I find that my C is equal to 90.66 meters. Okay, so that is going to be the magnitude of my displacement, but now I need to find my direction. Okay, so in order to do that, what I can do, since I have this side and I have this angle, I can use it to find this whole angle in order to solve for my direction. Okay, so I'll use this side, and then I'm going to find this angle using my sine law. So For my sine law, I'm going to be using A over sine of A and then that is equal to C over sine of C. Okay, so plugging in the information that I have 110 over sine of A is equal to side C, which I found to be 90.66 over my angle, which is 35 degrees, or sine of my angle, which is 35 degrees. In order to solve this problem, I'm going to cross multiply. So I'll have 110 times sine of 35. I'll divide both sides by 90.66 in order to get sine A by itself, and then I'll have to take the inverse sine of that in order to find A, or isolate A. And so what I find is that A is equal to 44.1 degrees. Okay, so looking at our angle here, you can tell that this is definitely greater than 44 degrees, so it's ambiguous. So what we need to do is we do need to subtract it from 180 in order to determine what this angle is. So our 180 minus our 44, and we'll get that this whole angle A, so angle A is equal to 136. Okay, so that's not going to be entirely helpful for solving what the direction is, okay, because we can't go off of this line. So we need to figure out what this would be, okay, or what this portion of the angle would be so that we can give the direction based off of the southern line. Okay, so we have 15 degrees here, which was given to us in the problem. Okay, we know that this here would represent 90 degrees. Okay, so if I take my whole angle, 136, I subtract 15, subtract 90, I get left with 31 degrees. Okay, and so that's from the southern border to the east. So whenever I go to report my final answer, delta D, again, look back at my problem. I have 2 sig figs here, 2 sig figs here because the 0 drops off. Remember, we don't look at the degrees in order to determine sig figs. So I'm going to have 2 sig figs that I need to report, so I will round to here. The 6 will round up the 0, so I will have 91 meters, and then for my direction, it's from the southern border, 31 degrees to the east.